I would like to thank the Lake Committee for the opportunity to present findings from my research today. This project started a few years ago when the idea of tagging juvenile cisco was brought up at a Lake Huron Technical Committee meeting. At the time, the cisco stocking program was ramping up, but hatchery-reared fish had not been released yet, and survival and movements were completely unknown. So for the rest of the talk today, I'm going to focus on our use of acoustic telemetry to understand movement and survival of cisco in Saginaw Bay. Before I get started, I would like to acknowledge the many people and agencies that have contributed to this project. The Great Lakes Fishery Commission was the primary funding source. Historically, Saginaw Bay supported a large cisco fishery, but in the 1950s, populations declined rapidly and have not recovered. Extant populations today are limited to the northern Lake Huron, Georgian Bay, North Channel, and St. Mary's River regions in Lake Huron. One goal of management agencies is to restore pelagic cisco populations in Saginaw Bay by stocking juvenile fish reared from the Lachino Islands broodstock. Understanding the movements and survival of these stocked fish post-release is critical to guide the stocking activities. Advances in acoustic telemetry have resulted in tags that can be implanted in juvenile fish. As well, tags can be programmed to change code when a fish is consumed by a predator to provide information about the fate of the fish. The specific objectives of our work that I will be discussing here today are to determine the proportion of hatchery-reared juvenile cisco that dispersed 4 kilometers in 4 weeks, determine whether dispersal coincides with changes in water temperature or water currents, and determine the proportion of cisco consumed by predators. Prior to starting this study, we expected newly released cisco would congregate near the release location and slowly disperse from that area. So moving on to methods, we implanted 26 fish from the Jordan River National Fish Hatchery with Innovasea V5D tags. These tags have about a 90-day battery life and are designed to broadcast the time since the fish was consumed by a predator when the tag encounters digestive fluids within a predator's stomach. Total length of the fish that we tagged was about 160 millimeters, and fish were held for about 2 weeks after the surgery in the hatchery before they were released. So in the bottom left map of Saginaw Bay, fish were released at the red marker near the Whitestone Point, and they were released from shore. In the middle image, you can see the 60 receiver array used to track the tagged fish. Each red circle is a receiver, and each arc of receivers is spaced 1 kilometer. The picture in the bottom right is the V5 tag that we implanted in the cisco. Where were the cisco detected? In this animation, you will see movements of all tagged fish after their release. Each colored circle is an individual fish, and if a fish is consumed by a predator, the circle changes to a red X. Time is shown on the bottom of the animation. What you will notice is that fish moved extensively throughout the array, but most left the array within a few days. In total, 7 cisco broadcast the predation signal and were consumed while in the array. This slide shows where the fish were last detected in the receiver array. In the left pane, most fish were detected on receivers to the southeast of the release location. The release location is at 0 in the center. In contrast, most of the predators that consumed cisco were detected in the northeast quadrant of the array. These results hint that cisco released may not be doing the same thing as the predators, but it should also be noted that the sample sizes here are quite small. In conclusion, all fish tagged survived the surgery and were detected immediately after release in Saginaw Bay. Fish were held in the Jordan River Fish Hatchery for about 2 weeks after surgery to make sure tags were operated correctly and allowed fish to recover. At release, all tagged fish were visually acting the same as untagged fish. 95% of the hatchery-reared cisco either left the array or were consumed within 6 days. At the start of this study, we hypothesized that cisco would spend a period of time within the nearshore area where our receiver array was located before dispersing offshore. The time needed for the fish to disperse was much less than expected, and fish did not return to the array before receivers were recovered in early December. Most cisco were last detected in the southeastern portion of the array, in contrast to the final detections of predators that were concentrated in the northeast quadrant of the array. Of the 26 fish, 7 broadcast the predation code during the first 16 days after release, resulting in an overall survival rate of 73%. The fate of the predator or tagged cisco after they leave the array is unknown, and it is possible that some cisco were consumed within the array but were not detected because the predator left the area. Our results suggest that the time that a predator was detected ranged widely. Some predators left the array soon after consuming a tagged fish, but others stayed in the array for several days. This suggests that survival is likely lower than 73%, given that an unknown number of cisco may have been consumed and the predator left the array before being detected. In the near future, I plan to investigate the relationship between cisco movements and the modeled water temperatures and modeled water currents. Stay tuned. Last, if we are interested in learning more about cisco movements in Saginaw Bay after release, we will need to increase the size of the receiver array to monitor fish movements over a longer time period. Our results suggest juvenile cisco can move substantial distances in short periods of time. Thank you.